Assalamualaikum. My name is Nukariniza binti Ahmad, HF220015.
Hi, my name is Nuriza Fakia binti Suhalil, HF220016.
Hi, my name is Putrina Azrina binti Ishaq, metric number HF220010.
My name is Abdul Nasir Mukhtar. Hello, today I'd like to present our project of structural frame analysis in part of the executive and introduction. My name is Abdul Nasir Mukhtar. This executive summary gives a general overview of the study performed using a software like Study Pro on a simple 2D frame structure. This frame analysis lets us comprehend how the structure behaved under a compliant load condition. We were able to observe and measure a loading-related displacement due to the analysis. This data is essential for evaluating the structural behavior and the performance stability. The study aimed to assess the structural performance of the frame under different loading scenarios, the analysis of the deformed shape plot, and also force of axial and shear force, as well as the bending moment diagram, provided all variable insight into the structural behavior. These findings can serve as a reference for decision on a member sizing, design, enforcement, enhancement, and overall structural integrity. In order to ensure that the results are accurate, it is necessary to consider the constraints and the perception established during the analysis process. And as we know, in civil engineer, frame analysis entails using a mechanical and structural principle to identify the external force, moment, and information that developed in the frame under different load scenarios. Engineers can create the building safely, handle anticipated melodies, can survive environmental elements such as earthquake, wind, and also other external pressure by looking how frames respond to the applied load. To evaluate forces, deformation, and the performance of structure, engineers use techniques that include a stiffness method, finite element analysis, as well as a matrix based on structure analysis. Also, they establish the proper member size and connection, locate regions of stress concentration, also optimize the design for safety using a frame analysis. The frame analysis helps the design process and also enabling the creation of a strong and effective structure that can endure the demand of their intended usage of environmental circumstances by using a computational methodology and engineering concept. Next, we move to modeling and analyzing a simple 2D frame structure. As we know, a 2D frame analyzing has a multi-step procedure. Consider using the stiffness technique and the finite element analysis as a suitable structural analysis method. This method enables us to numerically represent the geometry, material properties, and loading condition of the frame. In addition, the model analyzes a simple 2D frame offers a significant perspective into the structural behavior such as loading distribution, stress concentration, and failure process. The frame analysis technique used provided a comprehensive understanding of the structural behavior under both loads. Insight from the deformed shape plot, actual force diagram, and shear force diagram, as well as a bending moment diagram, were valuable for assessing structural integrity, identifying the potential issue, and guideline design decisions. Considering these findings ensures stability, effectiveness, and the long-term durability of the structure.
For part 1, which is modeling, it contains of the material properties, boundary conditions, and also the loadings. As shown in the diagram, this is the three diagrams of the 2D frame structure, and here we have the connection details of the roof member and also the connection details of the column. For the next part, which is material properties, we propose to use the universal beams of 127 times 76 and 13 kg of universal beams for the column and labeled as R1. Here is the physical properties and also the material properties of the column. Next, for the roof member, we use 70 times 70 times 6 equal angles, and we label as R2. So here is also the physical properties and material properties of the roof member. And for the boundary condition, we have three load case, which is the first one. Load case 1 is for the self-weight, and load case 2 for the sway load. Also for the load case 3 is the combined loads of load case 1 and load case 2. And for the loading here, for the support, we use the fully fixed, and support reaction, we assign on the Fx and Fy directions. So as we can see in the diagram, R1 is labeled for the columns, R2 labeled as a roof member.
Next is analysis and discussion. This part is divided into 4 parts, which are a deformed shape plot showing displacement caused by the imposed load. Okay, this slide show the evaluation of the deflection of member when negative 10 kN imposed loading is applied at each joint, and the load that caused a sway in this frame is a 5 kN. The red line show the effect of sway of the frame, and the column undergo compression while the beam undergo compression. Secondly is an axial force diagram, shear force diagram, and bending moment diagram. For this part is axial force diagram. Okay, stress parallel to the member that create compression move the axial force diagram one direction, while forces that cause tension move it the other way. Okay, as long as the compression and tension side of the figure are identified, it doesn't matter which direction is which on the diagram. The member is put into the compression by 10 kN vertical reaction force at A. Therefore, we move the axial force diagram to the right by the same amount and mark that side as being compressed. Okay, up until point B, which has a force of 10 kN that would generate tension in the member if it push away it from B. As a result, the member axis is at 0 and the axial force diagram is pushed back to the left. For shear force diagram, since the shape of the shear force diagram is linear, then the shape of the moment diagram should be parabolic. The shape of the parabola can be identified by sketching in the slope of the moment diagram at both ends and by identifying location of a zero slope, which are the point where the shear force diagram equals to 0. Lastly is bending moment diagram. The value of the maximum moment is easily found by adding the moment to the area under the shear force diagram in the previous figure. To find the area of that triangle, we need to know the length of the base. This may be found using similar triangles. This is the location of the point of maximum moment, which should be identified on the moment diagram.
Conclusion. From the analysis, the important findings that follows may be drawn. First is shape deformation. The shape deformation plot displays the displacement brought by the applied loading. It gives a visual depreciation of the structural deformation and demonstrates how the frame reacts to the applied loads. Second one is axial force. An axial force diagram shows the internal force that the frame's components are subjected to, whether they are under tension or compressions, assisting the identification of trouble spot that could be need to further consideration. Then the third one is shear force. The distribution of shear force over the length of the frame member is seen in the shear force diagram. To assess the frame structural integrity and make sure that the component can bear the imposed load without falling, it is very essential to understand the shear forces. And the last one is the bending moment diagram. The bending moment diagram shows how the bending moment vary throughout the lengths in the frame. They help in design of suitable member sizes and reinforcement to withstand the high bending loads by offering insight into the bending behaviors of the structure. That's all from us. Thank you.